Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Ashraf bin Azhar, DE 16006. Today I will present about my final year project 1 on slide presentation. My supervisor is ATS Muhammad Fauzi bin Zakaria. My first panel is Mr. Muhammad Fazli bin Abdul Shaib, and my second panel is Dr. Muhammad Najib bin Nubuan. Next slide. My project title is Poultry Farm Mobile Robot using Robot Operation System ROS and Weybot. Project background. So poultry as a farming activity already exists for age during 20th century. So today at dairy farming, a significant part of the daily animal care is mechanized. Wide range of technology will enable the transition of agricultural robotics into the field. So the problem statement is chicken are somewhat given to inertia, and this is the problem that we try to reduce the level of ammonia in the poultry house. The objective is to design and develop a 3D mechanical poultry farming robot in a simulation software, and to develop and simulate an application software in ROS framework and simulation software. So the scope is the project is utilize this use of simulation only. So the size robot is 20 cm times 20 cm. Using 4-wheel differential drive system for poultry house terrain, and using ultrasonic sensor to detect birds and terrain. So the methodology, the apps that I use, the Webots. Webots is an open source and multi-platform desktop application used to simulate robots. It provided a complete development environment to model, program, and simulate robots. It offers a rapid prototyping environment that allows to create 3D worlds with physics properties such as mass joints, friction coefficient, etc. These robots can have different locomotion schemes such as wheel robots, leg robots, or flying robots. Moreover, they may be equipped with a number of sensor and actuator devices such as distance sensor, drive wheels, camera, motors, touch sensor, emitter, receiver. Webots can execute controllers written in compiled C and C++, Java, or interpreted Python, MATLAB language. So this is the base that for direction of X is 0.1 meter, direction of Y is 0.05, direction of Z is 0.2 meter, which is dimension of the bottom are 10 times 20 centimeter and 5 centimeter thick. This number is depending of the size of the poultry used. So, but basically this is the robots that I'm going to create is mobile and not so big in size. Legs, there are 4 legs in this robot. The legs are the most assemblies of the robot because they have major function to keep maintaining ground contact. All 4 legs have each joint, which hinge joint was used. The hinge joint can be used to simulate a rotation motion. Spring and damping behavior can be specified. Much like door hinge joints only allow for one plane of movement. So we can see there's 4 legs attached to wheels. So the robot has 4 identical DC drive motor. The rotational motor node can be used by a robot controller program to generate a rotational motion around its hinge axis. There are many different sensors used in robotic field, but we use drive motor, and the sensor is a distance sensor that located in front of the body that face direction, a slightly different direction to left and slightly different direction to right, as we can see. And the power, this power robot use power to run. For simulation there are no battery used, but the prediction of expectation on further research will be integrated on total hardware. So battery will be going to use. The battery pack will be 24-volt lithium polymer, as known as LiPo battery. It has high specific energy up to 110 watt per kilogram compared to another NIMH or any acid batteries. But the advantage of this battery are cost and charging process. So the software is ROS Robot Operation System is a framework for robot software development, providing operating system-like functionality on top of heterogeneous computer cluster. ROS provides standard operation system services such as abstraction, low-level device control, implementation of commonly used functionality, message passing between process, and package management. It is based on a graph architecture where processing takes place in nodes that may receive, post, and multiplex sensor, control state, planning, actuator, and other messages. The library is geared towards a Unix-like system, and it is supported under Linux, experimental on Mac OS, and has partial functionality under Windows. So it is yet to be used by me, but because the webbots that I use only works in Windows, so this is the expected from PSN2 that I will be using Ubuntu and operate on ROS by Ubuntu. So the expected result, the integration of ROS into this project using Ubuntu, testing of aeration sanitizing tasks to reduce the level of ammonia in the barn, robot navigation control, testing for each part of the robot expected to engineering elements. So the initial result I will explain using webbots that I already created. This is the environment that I create. This can be globe, and that now I use a rectangular shape and has boundaries here, and the obstacle can be anything, can be but I use as a simple box to act as uh, avoidant, act as a so the sensor will detect. So first I will explain about the programming that I use. So here includes webot distance sensor, include webot's motor, includes webot robot. These are the we import the library for distance sensor and motor and robots for the movement and the sensor. And after that, this library that we use, and after that we define time step 64 using namespace webbots. So we use distance sensor and we save in the dynamic memory, and we name it as ds right and ds left. This is for the sensor. Then we save this to the get distance sensor, and we enable the time step. So and every 64 millisecond the sensor will show reading. And next the motor. So the wheels that we use is wheel 1, wheel 2, wheel 3, and before that later I will explain. This is the name that I present. So robots are to get motor is saved, and we set the position to infinity, and set the velocity to 0. And for the avoidance obstacle, we uh, as we can see, this is the value that we get the below 950 950. So the if the sensor for the obstacle, so get the value below 950, and we have the counter, it's here is 100 in the counter. If 0 and it has obstacle, and it will turn to right, and if it's 0 then no obstacle, it will straight, and because one here is straight, and is set the velocity, right wheel right speed, and left wheel left speed. So that's all for the programming, and this is for the this is for the environment that I use. The floor size and tile size, this is a wall height that we can change. Now it's 0.2. For the this is for the wooden box, that it can be anything. It can be it can add, we can add anything. uh, Loading, not responding. And then you can see that we can use base node. It has charger, differential wheels, as we can see, directional light, fluid, forks, and we can use body, wheels, and sensor. So this is for add nodes. So I will show the robots. This is the translation of the robots here for the XYZ direction. uh, Meter from the center of the environment, center of the tiles, and this is for the hinge joint. It's 4 joint. We have 4 hinge joint here, 1 2 3 4, and the device we use is rotational wheels, and we can set the max stop position and the velocity. uh, so next, for the this is for the distance sensor, and ds left and ds right, and the translation here xyz. So we can also change the distance that used in this sensor. We can go to lookup table. As you can see now, is 0.1 meter to 1000 meter, the minimum and the maximum reading. So we can change this too, and that's all I think. And if we simulate this, so the robots will now facing the so it changing. If it's circle, it will turn to right, and this is basically obstacle avoidance programming for this robot for now. But later I will put add GPS for the directional on top of this motor, on top of this body of this robot, and this is planned to be put in the barn environment to put move to make the chicken move. And on top of that, uh, back of this body, I will put a sensor that will act as a scratch for the for the ground to release to reduce the initial to ammonia gas that bring harm to the birds chicken. And for the directional that if we want this robot to go the direction that we want, that we already set, and that will be uh, uh, my expected result for PSM2. So that's all. Thank you.